All right, we are working now on problem 3-12. We're going to create a Cavalier Oblique here of this pictorial drawing. Again, the same type of situation. Make sure that your units are in millimeters because that's what this drawing is in millimeters. And we're going to start by drawing the front viewing plane. So everything in our frontal viewing plane, so our height and our width are going to be the same, and then we are going to extrude back at a 45-degree angle for our oblique in the depth view. So we're going to start by drawing that shape, again, just using the line tool, and as I go through, I can just type in the different dimensions, 200. Make sure that you're using the auto snaps and clicking. Remember the difference here between the left click versus enter as far as whether you stay in the line drawing tool or taken out of it. This is going to be 45. Left click to place it, staying in the drawing tool. Make sure you're using the auto snaps. This is going to be 40 millimeters because we know that 200 minus 160 is 40. I'm auto snapping at that perpendicular constraint. Left click, bring it down. I'm taking 45 minus the 20, so this line length is going to be 25. Make sure that you're auto snapping again. And now this dimension is going to be the length of this line will be 160 minus the 30, which will be 130. So typing in 130 on that line length. Auto snap into perpendicular, left click, move up. Here I am the 80 millimeters minus the 20. So this is going to be 60. So now notice I'm going to do something right here. So I just kind of got off of my perpendicular constraint, which is okay. I'll show you how to fix this. So let's go ahead and bring that over and put that in line. Now there's a couple of different ways that I can do this. So let me escape out of that tool. Notice I can kind of bring it in. So if I am like this, we can just bring this in. So left click on the point, so and hold it, and then you can kind of move and auto snap it into that position. So, or you could basically kind of use your perpendicular constraint. So right now it isn't perpendicular, so we could kind of come in and maybe use the constraint there for it. But in this case, it's going to be perpendicular. So here, and of course, if I'm at 60 there and I've got the 25, don't necessarily assume that some of these other constraints are taken care of. We need to make sure that dimensionally this line is the same height too, and in this case it is. So there's your 80 millimeters, and we have that dimensionally constrained. So now our depth is a depth of 100 millimeters. So we're going to do this at 45 degrees. So every place we have an intersection, we're going to project back a straight line at 45 degrees. So here's my line, 100, tab over to 45, hit enter to place it, right click, repeat the line. I'm going to do the same thing here, 100, tab, 45 degrees, enter to place it. Right click, repeat line. Come in here again, 100, tab, 45 degrees, enter. We're doing this at every intersection point. So on these lines, so 100, oops. So that one I picked that up right away, 100, tab, 45 degrees. So right click, repeat the line. So now I'm up here, 100, tab, 45. So right click, repeat the line, 100, tab, 45, and then right click, repeat line, 100, tab, 45. All right, now I've got those in, and this is, again, we're seeing all these dimensions. We're really needing to kind of pay attention and not get too bogged down with what's going on and what we're seeing here. So now we're going to very carefully go back and connect the dots. So I'm going to start right up here at this endpoint. We're going to go to that endpoint. Notice that connection. Right click, repeat the line, going down to here. So we're kind of filling in what these rhombuses are here. So from here over to there, you should start to see all of these fill out. So from this point to there, from this point to there, and then from this point to there. All right. Now, so that I don't change these, let's kind of see if we can get some of these off of where we want them to be, just to kind of keep things from getting too cluttered. So let's kind of put this right on the line here. So I'm just kind of moving some stuff around to maintain and keep these dimensional constraints, but also to help us see and view this a little bit better. So as we kind of go in here with these lines and positions. So again, I don't know that this is the best way to kind of view or create a oblique, but it's to me, this is more of a practice in visualization technique. So I'm going to bring these back, and so I do want to kind of maintain some of these at the moment because I don't want to lose these dimensions and lose the possibility of having things go crazy when I start to kind of cut stuff out. Now, hopefully at this point, if you are able to visualize this, if this were in AutoCAD or some other type of drawing, this line from right here would be a hidden line. So would this, and so would that. From this point to there, those would be hidden lines because they're hidden behind our view. So for right now, we're going to go ahead and I'm going to click on these and delete these out. So I'm going to get rid of that one. Oh, I didn't want to get rid of that one. Let me kind of come back through. I get rid of that one. Now, since I don't want to get rid of that entire line, I'm going to use my modify tool and I'm going to trim that out. So let's move this dimension here back down on top of that so you can kind of see. All right. So this is essentially what this shape would look like when we project it back at 45 degrees as a Cavalier Oblique. So if you can visualize and get this far, you're in pretty good standing as far as understanding the visualization here of our engineering drawings and engineering graphics. Again, to me, I think that this is predominantly a exercise in visualization, just to make sure. I've never really seen or had these particular style drawings being used on a factory floor. You might see these in marketing material or other types of literature, but to me this is purely a drafting exercise just to help us understand and get some visualization techniques here to help us be able to see how these shapes relate when we kind of start to move and manipulate things around in our mind. So we're going to do a real quick save here. So this is going to be P, make sure that it's a capital P3-12 hyphen, and this is going to just be labeled as our oblique. So you should know the difference between a cabinet oblique and a Cavalier oblique. So, and then of course hyphen your first initial followed by your last name. Make sure you're saving it in chapter 3 problems. So, and that finishes up with this oblique. At some point we will come back and we'll open this up and I will walk you through how to actually create the slot and the holes on this as well.